In this lesson, we're going to tie our velocity to our drag and angular drag. Alright, so let's get right back into the script. So we have our movement functionality here, and now we want to create some variables that are going to allow us to create velocity and then also tie that velocity to the drag and angular drag to give us a little bit of a different experience in driving. So the first variable that we want to create is going to be a float variable, and it's going to be called current speed. Now the current speed is going to equal math.f.abs. Now abs is absolute value. So the absolute value is always going to be a positive number. So whenever I'm driving in 3D space, no matter if the z direction is pointing in a negative direction, we're always going to get a positive value, okay, for our current speed based on our velocity. So what I need to do is I need to get the absolute value of my transform of my object, and I'm going to base it on its inverse direction, so inverse transform direction, and that's going to be based on the rigid body dot velocity, and the velocity direction that we want is going to be dot z. And we're going to end that with semicolon. Okay. And then once we have our velocity variable set, what we want to do is we want to tie that to our angular drag and also our drag. Now what I want to do is I want to start out at a specific drag number, so at 1.0. And then as we gain velocity, I want it to increase that drag or decrease that drag. And same thing with our angular drag. So whenever we slow down, that drag will come back down to its normal value. So the way that we're going to do this is we need to create a max angular drag variable. So we're going to come in and we're going to say float max angular drag. And I'm going to set this value to 3.0. Actually, let's do 2.5, as I've tested that and it seems to be a little bit more of a stable number. And let's do another float value, and let's say current angular drag. And let's set this value to 1.0f. And I'm going to go ahead and pull these out a little bit more, so that way they're nice and neat and easy to read. And then whenever we have the current angular drag and our max angular drag, what I'm doing is I'm creating a function or an equation that is going to be using linear interpolation. So linear interpolation is represented by lerp. And if you look up mathf.lerp for Unity, you'll see that the function for that requires a current number, a max number, and then a time in which that is supposed to go between the two numbers. And so what I'm going to do is I'm going to set a float value, and I'm going to say a drag for angular drag, lerp time. And we're going to set this equal to our current speed, which is going to be our velocity of our car, and we're going to multiply that number that we get by 0.1. Okay, now the reason that I want to multiply it by 0.1 is the lerp time must go from 0 to 1. It cannot exceed that. And so setting it to current speed multiplied by 0.1 is going to ensure that it is between 0 and 1. Okay, so now that I have that, I'm going to come in and I'm going to say, or get my variables for my drag. So I'm going to hit Control C and then Control V, and let's just remove angular from these variables. So we'll do current drag, and then we're going to say drag lerp time, lowercase d on this one. And on my max drag, I want to switch these values. So I'm going to change this from 2.5 to 1.0. And then my current drag is going to be 2.5. Now the reason that I want to do this is because the lower the drag, the faster the car can move. And so whenever the car's velocity is increasing, we are getting more drag out of this. Okay, now let's remove that R from right there. There we go. So make sure that those values are set. So under your angular drag, your max angular drag is going to be set to 2.5. The current angular drag is 1.0, and then it's the opposite for your max drag and current drag. So now that we have these values set, we can start setting these to some variables that are going to hold this data. So I'm going to say float my angular drag, and I'm going to set this equal to mathf.lerp, which is a linear interpolation. And we're going to set this to current angular drag. And then we're going to say comma max angular drag. So it's going to go between these two numbers. And it's going to base that off of the a drag lerp time. Okay. And then we're going to do another float value called my drag. And we're going to set this equal to mathf.lerp. And this is going to be based on current drag, comma max drag, comma drag lerp time. And there we go. Now that I have these variables that are holding this data, I can set those variables to set the rigid body angular drag and drag of my object. So to do this, we say rigid body dot angular drag is going to be equal to my angular drag, semicolon, and then the next one is going to be rigid body dot drag equals my drag. And there we go. So now that we have this set, let's hit save. Let's go into Unity and see what we have. Let's hit play, and you'll see that as we begin to move forward, those values are going up. We're able to slow down very quickly. Okay, the angular drag is working very nicely, but I kind of noticed that it goes pretty slow. Even if my velocity is getting higher, my angular or my drag is still just a little too much. Kind of just sticking around the same value there. So what I can do from here is I can start to play around with the speed values to really dial that in. So I'm going to bump this up to 12, and I think this is going to give me a pretty good value to start driving around on this. So pretty happy with that. Starting to get a little bit of sliding around. Have to do some counter steering. Okay, so looking good. I'm pretty happy with the way that's sliding around and how I have to move. So at this point you can come in and you can start to really work on this. All right, so one thing that that we still haven't worked on yet is that if we release the accelerator, so if we release the W key, we're not able to turn. So what that means is if I want to slow down without braking, I just want to be able to turn the wheels, and it's not doing that for me. So what I need to do in the next lesson is I need to modify that a little bit. And so what we're going to do is we're going to optimize the movement script a little bit more to be a little more realistic as far as how the player is going to play. So I'll see you in the next lesson.